Hey everyone, welcome back. So previously I posted a book review about this title called AI Product Manager's Handbook. And I've got quite a lot of feedback from a couple of the audience. So I thought in this video I'm gonna select a couple of questions, a couple of feedback from the comments I received and talk about these comments because I think these are some of the most important questions. And they also happen to be the most frequently asked questions by not just the audience from YouTube, but also students as well as colleagues and potentially from industry as well as classmates previously, basically from all over the places. So in this video, we're going to dive into a couple of important questions that get asked about how to become a product manager, specifically in AI ML space. So the first question is, how do you make that transition? Now, I think that's interesting because most people, they kind of stay in their lane, meaning that you have some sort of roadmap planned out from when you were in school, when you were in student, and then after that, your career start taking off and you kind of stay on that lane until you probably hit a roadblock somewhere, and then you start thinking about changes. So the question is, how do you transition from being a data scientist to a product manager? Now, here's what I think why this question is interesting. Because from everything I've seen, I don't think it's necessarily a binary transformation. It's not like, hey, here's a line, you cross that line, you are no longer a data scientist, and now you are a product manager. I think that line is most likely very blurry. And in most cases, in most scenarios I've seen, it's not a line, it's usually an area. So what that means is, as a data scientist, you want to think about a product. As a product manager, you also want to think about how data is processed, how data can be modeled, what does the code structure look like. You may or may not know how to write the code, how to build the model, how to train the model, but you kind of have the knowledge of, hey, data needs to come in from somewhere, and then someone needs to build a model, things like that. So it's not binary, it's more like an area. And based on that premise, what I would say is, if you want to go from one end to the other, you want to kind of have the ability to zoom in and zoom out on pretty much every building block that you're doing. For example, anyone can go online and find some code in TensorFlow or PyTorch to build the image classifier, to train the AI model, to learn that, hey, it's a cat in the picture, not a dog, or vice versa. The task to do that, it's not that hard. It's actually, in any ways, very simple. But that's from modeling perspective, and purely from modeling perspective. If you're gonna take a step back and think about, on a macro level, how that project could plan out, you're gonna start asking all these questions such as, hey, why is it even interesting to train an AI to learn if this is cats or dogs? What is the use case here? And if you start thinking along those lines, then congratulations, you are kind of already on the path to transition yourself from being a data scientist or purely a data scientist to a product manager, right? Maybe we're talking about some sort of animal shelter, that the animal shelter have both places for cats and dogs, but in regards to the operation and management of the shelter, obviously they don't want them to overlap, right? The cage for cats is the cage for cats, and vice versa, it's a cage for dogs. And the use case here can be, hey, let's put a camera here. If there's anything in a dog cage that's not a dog, let's draw a bounding box, let's flag that whatever object it is that we see on camera, let's send some staff member in there to take a look what's going on. So that would be a use case of how this project can be turned out in production in a real world application, even though in terms of model itself, you are just building an image classifier to recognize dogs versus not dogs, right? And if you are on that road, don't stop there, right? Think about what's coming up next. Well, you need to have a camera, right? There's some sort of hardware device physically in the room to get that data for you. And then on top of that, you need to think about, now I have this device, what kind of data are we talking about here, right? Well, the camera captures videos, and videos is frame by frame objects. So really, they're pictures with timestamps. Okay, so you have a device constantly sending in pictures frame by frame. Are you gonna save the picture somewhere, or are you just gonna run the algorithm on the spot? So these are great questions to have, and the answer to these questions will help you guide how do you build that data ingestion pipeline. So now the situation is already getting very cloudy right now, right? We don't know what the data ingestion look like. We don't know if we're gonna run this algorithm on Prem, or if we're gonna download a video for 8 hours a day and then you run the algorithm overnight or anything like that, right? What kind of context are we talking about? What kind of framework are we talking about? And then why, right? You're gonna run it on Prem, okay, how fast is your camera, and is your AI inference speed gonna be able to catch up with that camera speed, right? Or if you're gonna download this locally, well, we're talking about a camera downloading 8 hours of video every day. That's not a small data, that's probably gonna be a big data. And we're gonna store that information, right? If it's a HD video for 8 hours, that's probably gonna be gigabytes of files. Are you gonna physically save the files in the Google Drive? And if you're gonna save files in the Google Drive and this camera is running on a daily basis, who's gonna pay for that, right? The Google Drive is not free, right? When you hit a certain limit, you're gonna run out of storage spaces and you're gonna have to pay for it. So these are the questions that a product manager should be asking. The product manager may not have the answer, but the product manager should be able to think about, hey, we're not just building a classifier anymore. There's a whole lot of other things surround this classifier that need to happen, that need to be addressed, need to be answered before this classifier can actually go into a physical space, before this classifier can be actually deployed in production and to generate some sort of impact. And even then, there's no guarantee that everything that I just said covers the full story, right? It's an ongoing process, it's a continual learning process, and we need to have the system in place, have parameters set up, and then we need to evaluate and measure these parameters on a day-to-day basis so that we can know that whether the system that we put in place is helpful, is generating impact for the animal shelter. So then the question is, okay, how do you measure the impact? Well, there's upside, there's downside, right? Upside is with the system in place, you can measure and flag the unwanted outcome in the shelter before you send a staff member in there. Then maybe you pay less hours for the staff member to be on site, right? Whenever there's a problem, send someone in there. Don't just put person there on shift 24/7, right? So now all those questions will help you define what the KPI is. So now we're talking about KPI, right? In industry, that means key performance indicators. Every project that's being run, every project that's being debated on the table, there's always a product manager or project manager always have to ask, what is KPI? What is the definition of the KPI? And how do we lead this project forward? And the further you envision this project moves in production, I think the better you need to define and spend time on defining what the KPIs are. So there you go. In those small example, what I just walked through is to start with a very simple image classifier, cats versus dogs, and immediately expand to not really give you a solution, but kind of show you how complicated things can get and things can turn immediately when you're gonna deploy something like that, as simple as an image classifier in production. So that's the first question. Now let's move on to the second question. So the second question is this. In the beginning of your career, such as undergrad or if you're a grad student, you don't really have much of the industry experience. Then what do you do, right? How do you gain that industry experience to think like a data scientist, but eventually to think like a product manager? So unfortunately, the answer to that question is a little bit of like, hey, is there eggs first or is there chicken first? And in practice, I think that's always going to be one of the difficult things, which is always to balance your school, your life, as well as what kind of project you're going to take on outside of school. I'll tell you how I did. When I was in school, I find something that I'm really interested in. Let's say I want to learn about neural networks. That could be something interesting, right? Maybe using TensorFlow code, using PyTorch code to do something online. In the beginning, I will stay in a notebook. You will go to your Google Colab, or you can download some Jupyter Notebook on Anaconda, set up your virtual environment, and then you can type in some Python code to see if you can build a model based on artificial data that's tailored from some publication. And then from there, you see if you can build some sort of model that have results that's very similar to what they've been discussed in the paper. Great, if you can do that, that will be the first step, meaning that you get your hands dirty, right? However the model performed, you at least saw the performance with your own eyes in a lab environment, right? You're not just listening on YouTube, you're not just reading a paper, listening from somebody else in a conference, right? You actually played around with the code and you understood what is roadblock there. So I can turn to my screen and show you guys most of my notebook are actually stored in Win Associates, GitHub repo. If you go to docs, and then down here, you can go to reference deep learning, and all these are notebooks that I save here. And they go by different topics, right? From exercise 0 all the way to, I believe I'm like on exercise 30 now. That's quite a lot of notebooks here. And then they go by different versions, right? Sometimes I play around with the code for a little bit, and I find this interesting, and then I go on to turn it into version 2, version 3, implement some new code, implement some new functions, things like that. So I start Python programming by creating the simulation here called creating pi, right? This is a simulation that I'm trying to re-engineering what is the empirical value of pi, 3.14. And you can, of course, learn Python by doing a small simulation like this. Now, later on, I realized, okay, that's not enough to learn Python just from that experiment. There's more to be learned, so that's why I have Introduction to Python, and that leads to the second notebook, so on and so forth. So now you kind of get the trend, right? Every single exercise that I created for myself, there's a notebook. And you just keep going, right? Maybe somewhere down the road, I want to learn about artificial neural networks. Hey, there's a notebook there, exercise number 2, that's right there. And then eventually I want to move on to convolutional neural networks, and I add that into this exercise 02. And then so on and so forth. As you can see, I start introducing 3D, I start using VIT, Vision Transformer, and then maybe talk about explainability, right? Class activation map, that's one of the important tools for explainability. And then maybe you can talk about autoencoder, right? That's going to be your usual image to image or sequence to sequence model, and that opens up a whole nother door, right? Because it's no longer just data comes in, make a prediction, and now we're talking about a high dimensional data coming in, and then you produce a high dimensional data. From there, things start to pan out, start to get interesting, and then when you get your wheels rolling, you start have more ideas, and you start want to see more data. So you get your hands dirty. I will call this step number 1. And then step number 2 is think about how this look like in production, right? I'll give you a simple example. Let's say I use a VIT classifier. If you open a notebook, it's a lot of junk, right? Oh, you have to load the data. Oh, you have to check the dimension, print the images, so you know what the image look like, right? And then after that, you have to import a bunch of packages. Oh, maybe you have to install it if this import doesn't work, right? And then you have to build your model, train it, so on and so forth. It gets very messy, very fast. And this is all happening in a notebook environment, meaning that you're still playing around with the code, right? You're just kind of eyeballing things, right? The code might even get very sloppy, and there's a lot of hand waving going on here, right? It's not clean code that can go into production. So if you can see that, and if you can see that happening to your current notebook, then what I would say is, okay, great, you are now starting to deviate from being a pure data scientist to maybe like a machine learning engineer, to potentially being a product manager. So a product manager will look at this and be like, okay, this is too messy. I don't like this. I'm not getting anything out of this. I don't really know what you're trying to do in this notebook. So a product manager might ask a question, hey, how do we productionize this? The productionize means that, hey, this model here, can we somehow turn that into some sort of API, right? You want to save it somewhere in a package. So a software engineer or a product manager will look at this and naturally they will go that direction. So what that means is, okay, let's take a step back from the docs, right? Because these are just documents, you're just exploring things, it's not very interesting. You want to think about, okay, what does this look like in a source file? Maybe there's a setup script somewhere to set up your software package, set up your Python package, and then you go to your source. And then in the source, maybe you have different scripts, right? Here I have a couple of folders. Every folder is a particular topic. For example, CV means computer vision, fin means finance, ML means machine learning, right? If you go to CV computer vision, there's an init Python script, and then there are all these scripts that can be loaded as a function. And then if you click into any of these, for example, let's click into modules, and then inside of modules, you see that the library is loaded and there's a class object, and then inside this class object, there are different functions. And then in the future reference, when I want to go back to Python, I can then call these functions right off the bat, right? Because I build these packages for myself, using myself as a stakeholder, and these are the functionalities that I myself will be using in the future. And that's how I pack things together nicely in a source file. Now, that being said, I'm not saying this code is perfectly written. It's actually in any ways not that perfect, right? And the reason is this. There's still a lot of junk in here. I pack a lot of things in this one folder, just this one folder. As you can see, this is a lot of files. And then if you take a step back, go to the source folder, you have like 6-7 folders here. So it's still too junky. It's still a lot of sloppy code writing style in here. Even though if you open a particular function, it might be clean, right? Let me show you a clean function. Let's say I have a vision transformer. A vision transformer is a class object, and then there's an init, right? That tells me what the variables are initiated. And then there's like functions here. I would kind of call this function relatively a clean function, right? There's type hints defined in every function, and then there's return, and then all these are nicely packed together in one class object. And this function, someone can just take it to go, right? You install the package, install the requirements, install dependencies, and these functions are there for you to use. Now, if you can see that, you are now thinking like an engineer. So if you can think like an engineer, these are great things to have, because these are reusable code that someone can just take it go, right? And that's making all our lives easier. Great. But if you are a product manager might look at this and be like, well, this is all great, but how am I going to use this if I'm a non-programmer, right? I want to be able to have many people be able to use this. Well, how are you going to do that? Well, in that sense, you want to go even a level above software engineer, machine learning engineer. You want to think in the front end, how the user interface look like. And this is when I find the front end design quite interesting. So from here, now let's even take one more step back. Let's say, hey, even this is too junky, too hand waving, lots of sloppiness here. I can't really see what's going on. Like, fine, this is a class object, but what does this thing do, right? I have no idea what's going on here. Great, if you can think about those questions, then congratulations, you are probably more like a product manager than a data scientist or an engineer for that matter. So if that's the case, I will then start asking questions. Okay, what if we build some sort of front end interface for your users such that your front end users, they don't need to know the model, they don't need to understand the code, they can click around buttons and they'll immediately get an idea of what this whole function is doing. Great, if you can do that, then congratulations. I would say you are then more like a product manager, right? So let me show you guys an example. So on my website, I have this YOLO demo here, and I click on this. So now here you go, right? I open this app and it's able to use YOLO algorithm to detect how many person there are inside of the camera. Now, of course, this camera is very blurry because I'm using my webcam and I'm using my main camera for recording this video. And even this code has error, right? It's not very well designed. There's one person here and somehow it says there are two people. So obviously I need to fix the code. We can check the code to see where the mistake is. But essentially this is a representation of what the YOLO algorithm is. So now I didn't even explain what YOLO is, and you probably get the idea, right? It's an object detection algorithm that if you turn your camera on, it will draw these bounding boxes targeting the object that you want to target. In this particular example, I'm targeting person. So it will draw a bounding box saying, hey, there's a person number 1 there, and then that's how it's doing its magic. So as you can see, this is a kind of an interesting use case that show you not what the project look like, but what the algorithm looks like in production. A front-end user, someone without the technical background, can look at this and immediately understand, oh, that's what this thing is doing. But it still doesn't quite answering the question, how would this look like in production, and how does it lead to KPI, right, the key performance indicator. So now you understand the technology, right? You play around with Python notebook. Doesn't really help you think like a product manager. Great, that's fine. Turn that into source code, turn that into a software package. Maybe we can talk, right? We've done that. It's still not quite helpful, right? We're moving forward, baby step, but still not quite helpful. We still don't quite understand how this works in industry, how this works in production. That's fine. We build a user interface, right? We saw on this app, right? Running this webcam live, and we see a bounding box. Great. That's how you demonstrate how a particular piece of technology works in production. But it's still not quite a project yet. The last thing I will say is draw up the KPI and then use the KPI to define the P&L of the project. If you can define a P&L project, then congratulations. I would say you're probably more of a professional product manager than a data scientist. And you can probably say, hey, that transition is complete. So here's how things work. You want to brainstorm with a stakeholder, right? If you're gonna put some sort of a camera object detection, that's like a cat dog classifier, why do you want to do that, right? What's the upside, what's the downside? Are you making money? Are you saving money? What kind of context are we talking about? And based on my personal experience, it probably always ends on a dollar number. If you can demonstrate someone that, hey, you got a successful project that can generate P&L, great. You probably have a project and you probably will become a very successful product manager. But this is a YouTube video. I don't really have another person to talk with me, so I'm going to talk to an AI. And for simplicity, I'm going to use Meta's new chatbot, which is backed by Llama 3. I can say something like this, right? I have an image classifier and I have a YOLO algorithm built with a user interface that can detect dogs versus cats 100% accuracy. How do I put this in production in a sense that I want to convince my boss that is a manager at an animal shelter that this project is worth putting in production. Now, of course, I didn't really type the sentence that well, but that's okay, right? This is just a chatbot. Obviously, the consequence is minimum. And I want to give the chatbot a couple of ideas, right? It's the same that you go to your boss or you go to your stakeholder. That's a real person. You don't want to just ask them, oh yeah, tell me what your goal is. Tell me what you want to do. That's not their job, right? Even though they might have some idea they want to do, but that's not really how you start a conversation. You kind of want to do your due diligence, do your homework, understand what the research problem is, and do the research yourself and come up with the solutions so that you can present the options to your boss, to your manager, to your stakeholder. And you ask them, what do they like? That will be a more concrete way to push the conversation forward. If you just say, hey, tell me what you want. They're gonna be like, oh, I don't know. Then the conversation stops there. You're going to a dead end in like 2 seconds, and it's not a good way to get a conversation flowing, right? So you do your research, right? Now, for example, I'm doing research here using a chatbot. So I say, pros, less human staff, maybe cheaper. So calculate some costs for me. This is gonna be cost reduction. Cons, maybe we need to pay for it, right? If you're gonna run an algorithm on Prem, or if you're gonna record 8 hours of video, download it, save it somewhere, like we discussed in the beginning of the video, you gotta pay for the storage, right? So pay for the storage and pay for running the algorithm. And then in the end, you kind of want AI to help you brainstorm a little bit, right? So use the pros and cons above to come up with a list of comparisons. Why or why not should my boss put the YOLO algorithm in animal shelter? And then hopefully Meta AI is going to give us something that's a little bit more human sensible, right? And then there you go. Here we have something that's kind of like human sensible notion, such that we can work off something, right? And if you brainstorm with your stakeholder, with your boss, that's a human brain, the conversation probably will work in a similar way, right? Why do you want to put this algorithm in shelter? Great. Pros, increase efficiency, cost reduction. And here are a couple of numbers you can work off with, right? Sure, you may disagree with the number, right? That's okay, right? That's okay, because these are just a template. You can always swap the number with whatever it is that you want, right? You can say, hey, this is New York City. It's not just an average of United States, right? This staffing cost is not $30,000. It's not $50,000. It's like $100,000, whatever, right? Whatever it is you want to say, you can break the assumption. You can update, replace the assumption. You can do whatever you want, right? But this kind of gives you a template to help you conduct that thought experiment a bit more before you walk into the meeting room to have that conversation with the real person. And then of course on top of that, you can decorate the story a little bit, right? You can say, hey, we got awesome accuracy, 100% accuracy, and we can scale this up, because if you have one shelter that runs this, it might be very costly. But if you run this on 100 shelters, the marginal cost might be very small, right? So all those things you can talk about here in the scalability, and eventually you want to show that marginal cost decrease, right? And then of course, 24/7, maybe, you can automate this. And then you can run this full scale 24/7 in your operations, right? So great, those are pros. What are the cons? Cons, well, the initial investment, you gotta start the infrastructure, right? The code need to stay somewhere, the data need to be saved somewhere, and you gotta install a video, right? Install a camera. So these are called initial investment. And then on top of that, you have storage, computing costs, blah, 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 right? Whatever these numbers are, once again, you don't have to agree with them. These are just templates. These are just assumptions. Feel free to change them, right? So, but you need to discuss something as a cons, right? As a downside, right? And these are some of the things that we brainstormed, right, with the AI just now, and that acts as an example. So there you go. If you put together this list and you can kind of figure out a dollar number, and then you go to your boss, you're like, hey, this sounds like it's generating some money for us, and maybe this is on a per week base, per quarter base, per season base. And then from there, you start thinking like a consultant, right? Hey, we're generating this cash flow, and then this is the future cash flow. Awesome. Let's do that, right? Now, of course, I'm not saying that's the end of the story. Chances are there's more nuance to it, right? This video focuses on how do you transition from a data scientist to a product manager. But of course, there's a whole lot of things on top of that, right? In parallel to product manager or on top of product manager, you also want to think like consultant, management consultant, strategy consultants. You also want to think like an executives. What is the net present value of your project, what is your free cash flow of the project, all that stuff that you learn from business school, all that stuff that you take from econ class, business class, corporate finance class, they all now play into this formula, right? They can then act as tools to help you think about, should you take on this project or not? So if you can think along those terms, then congratulations, you are no longer a data scientist, you are now a product manager. So with that being said, hopefully you like this video, and hopefully this video sheds some lights to all the students out there to help you guys think about what does it take to go from a data scientist to a product manager. Thank you, and I'll see you in the next episode.